Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is some important concepts of partial fractions. For this lecture, I am using the work of one of my best student, Miss Vania Jabin of class 2024, the Lyceum. An important advice: do good by everyone. Partial fractions. It means to split a single algebraic fraction into two or more fractions. In O levels, we learn how to add and subtract algebraic fractions. For example, if we have to express this as a single fraction, we need to take LCM of these two fractions. So by taking LCM of these two fractions, we have this single fraction. In partial fraction, we split a single algebraic fraction into two or more fractions. So the reverse of this process is known as partial fractions. Applications of partial fractions. The first application of partial fraction is it is used to expand binomial expansions of this type, where n is not positive integer. N could be anything except positive integers and 0. For example, n could be negative integers and rational numbers. The second application of partial fraction, it is used to integrate rational expressions by first splitting the fraction into partial fraction. So first we split this in partial fraction and then we integrate it. Note, while solving questions of partial fractions, first distinguish between the following three things. Number 1, types of fractions. Number 2, complete factorization of the denominator. And number 3, types of factors. Number 1, types of fractions. There are two types of fractions, proper and improper. Proper fractions. In proper fractions, the highest power of the variable in denominator is always greater than the highest power of variable in numerator. Let's understand this concept with the help of this example. If we will multiply these two terms to get the highest power of x, we will get 2x square. And the highest power of variable in numerator is 1. Since the highest power of variable in denominator is 2 and the highest power of variable in numerator is 1, which is, 2 is greater than 1, therefore this fraction is proper. Let's understand this concept with the help of this example as well. See, if we will expand this expansion mentally, we will get this term as 9x square. And when we will multiply this x with this term, we'll get 9x cube. Now observe the highest power of variable in denominator is 3. And the highest power of variable in numerator is 2. 3 is greater than 2. The highest power of variable in denominator is greater than the highest power of variable in numerator. Therefore, this fraction is proper. Improper fractions. Well, in improper fractions, the highest power of variable in numerator is either greater or equal to the highest power of variable in denominator. But in P3, the greater power is not in this syllabus. Hence, for improper fractions, only equal power is in this syllabus. See, the highest power of variable in denominator is 3. When you will multiply these two terms, you will get 2x cube. And the highest power of variable in numerator is also 3. Since both powers are same in numerator and denominator, therefore this fraction is improper. Another example of improper fractions. When we will multiply these two terms, we will get 2x square. And the highest power of variable in numerator is also a square. Since both are same, therefore this fraction is improper. So this is the way to differentiate between the fractions. The second step, the complete factorization of the denominator. So before splitting the given fraction into partial fraction, make sure the denominator of the fraction must be in its simplified form. So first observe this. See, this factor is already in its simplified form. You cannot simplify this further, x minus 2. But this can be factorized. So you have to factorize this. It will become x minus 1, x plus 1. So when you will factorize this factor, you will get this fraction. X minus 1, x plus 1, x minus 2. So this is the simplified form of denominator. Another example. This is the simplified form of the factor, but this can be factorized. So when you will factorize this, you will get x minus 3 whole square. This is the second step you need to observe while solving questions of partial fractions. The third step, types of factors. There are three types of factors in P3 syllabus. Linear factor. Well, this is the structure of linear factor, ax plus b. Because the power of variable is 1 and the power of expansion is also 1. And these are some examples. 5x plus 1, x minus 2, just x. X square minus 9 can be factorized. So these are two linear factors. This can also be factorized, x minus 3 and x minus 2. So all these are the examples of linear factors. Repeated linear factors. Ax plus b, this is a linear factor. And if you square this expansion, then this factor will become repeated linear factor. So linear means power of variable is 1 and repeated means power of the expansion is 2. This is the generalized form of repeated linear factors. So if you square these factors, you will get the repeated linear factors. Here are some examples. 5x plus 1 whole square. See, this 1 means the factor is linear and this 2 means the factor is repeated linear. Repeated means power of the expansion is 2 and linear means power of the variable inside the expansion is 1. So these are some examples. This is also a repeated linear factor. This can be factorized. So this is a repeated linear factor. Quadratic factor that cannot be factorized. When there is a positive sign between these two terms, then this can never be factorized because of this positive sign. So this is the generalized form of a quadratic factor. See, we cannot factorize any of these factors. So these are the examples of quadratic factors. There must be a positive sign between two terms. One is variable, other is constant. Rules for fractions. Well, I will discuss this in my next lecture, inshallah. Good luck and Allah Hafiz.